This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gavin Henry, and today my guest is Dave Cross. Dave has been programming professionally since 1988 and a Perl user for a very long time. I actually came across Dave in 2010 when I was a big Perl Catalyst user. He is the author of Data Mugging with Perl from Manning and a co-author of Perl Template Toolkit from O'Reilly. Dave runs and owns Magnum Solutions, an open source development consultancy based in London. His latest book is called GitHub Actions from Clapham Technical Press. Dave, welcome to Software Engineering Radio. Is there anything I missed that you'd like to add?
Hi, thank you for having me. No, just to emphasize what you said about my career starting in 1988, which means I am very old, and the fact that I'm enthusiastic about some of these newer technologies is because so much of my career was spent without them.
So you've seen the before where it was manual and everything we'll
Absolutely,
touch upon later.
This is so much easier.
Excellent, perfect. So we're going to have a chat about, obviously the show's about GitHub Actions. We're going to talk about the value they provide and discuss an example project that implements the main parts of continuous integration and continuous deployment, with a few surprises along the way out. So let's get started. Continuous integration and continuous deployment. Let's start with the basics. Dave, what is CI?
So CI, it's automating the bits of your project which mean that you can measure the quality of your project, I guess. It means that every time you commit some new code to your code base or changed code into your code base, you can run processes which do things like run unit tests, run a linter against your code base, and perform other quality metrics like maybe measuring the complexity of the code or the coverage of your tests, that kind of thing. The kind of numbers that might end up on a dashboard that is on a monitor hanging above the development team so that everyone who walks past the team can see how good your code is.
If you were to come across a new project on GitHub or your recommended one, what would be the first thing you'd look at to see what the continuous integration would be?
I think the first thing that I would be looking at is the coverage, just to see how well the test suite matches the amount of code that you've actually got in the project. Having a test suite that covers the code base well means that you have more, it's easier to change code and know that you're not breaking things.
Yeah, it gives you that safety net, doesn't it? And obviously you'd want there to be some type of continuous integration in the project.
Yes, yeah.
So that would be the first thing, hopefully. What is continuous deployment?
So that's the step that comes after continuous integration. It means that once you are happy that your code is good or even better than it was previously, then you can automatically take that code from your GitHub server or whatever source code system you're using and move it into production in a manner that is easy to reproduce. So hopefully just pressing a button and at the end of some processes running, the code is up on your production server and running.
Excellent, thank you. For the listeners who want to dig into CI/CD, continuous integration, continuous deployment more, we've actually done a full show on it, which was show 498 with James Sokol on continuous integration and continuous delivery. We've done episode 554 on behavioral code analysis, which was really good. Episode 544, 482, 440, 424, and an older one on continuous delivery, episode 221. I'll put those links in the show notes, but it helps expand on this very light overview I've just done with Dave. So before I move us on to the core of the show, which is GitHub Actions, is there a sort of low-hanging fruit to put into CI as a safety net and something in CD, or does it depend on the project and the software developer?
To a large extent, I guess it does depend on the project. But as I said earlier, I think getting your unit tests running in some kind of CI framework is very useful.
Excellent. And there's simple things on GitHub, like, I suppose it depends on the project, like the dependabots thing, or what's their static analysis one? CodeQL, I think it is.
Yes, yeah. And there's things that do things like looking for secrets and things like that.
Yeah, depends on what you've got in your project, I suppose.
Yeah.
Excellent, thank you. Right. So now we're going to dig into GitHub Actions. Most of the show will be spent between this section and the example project. Please bear with us. So Dave, what is or are GitHub Actions?
So GitHub Actions is, I was trying to work out when it was that GitHub Actions was introduced. I reckon it's about a couple of years old. And listeners may have come across product like Jenkins or Travis CI or Circle CI, which many projects or many of my clients are using to do CI and CD. GitHub Actions is GitHub's answer to that. It allows you to define workflows, and the definition of those workflows actually sit within your code repo. And then in response to various events, GitHub will fire up a container and run through the steps in your process, which allows you to do CI and CD, but it isn't limited to that. And as we'll, I'm sure, mention later, there are plenty of other things that you can do with it.
Yeah, I think for a long time, GitHub, as it was GitHub or before Microsoft, there wasn't any GitHub Actions, so you had to use one of those. And then they were quite late to the game, weren't they?
Yes.
For various reasons.
But I guess they countered that by coming up with something that is more powerful than Jenkins or Travis CI, because, as I say, it's not just limited to CI and CD.
Yeah, exactly. And you mentioned there that it does things based on certain events. Would that be solely defined as an event-driven architecture?
Yes, it's an event-driven architecture, but I suppose you need to be quite liberal in your definition of what an event is, because it's event-driven to the extent that you can trigger your workflow to run when something is pushed to your code base, when you get a pull request to your code base, when someone raises an issue in your code base, all these kinds of obvious source code control events. But there are other things. It basically gives you a complete cron job implementation. You can trigger events, trigger workflows on time purely. You can trigger workflows manually. You can get a button on the workflow page and say, just run this now. Or the other thing you can do is basically use it as a webhook. So you can just make an HTTP request GitHub and it will trigger your workflow. So there's plenty of different ways of running a workflow.
Oh, that's brilliant. One I wasn't aware of is the webhook option.
Yeah.
And I'd like to explore with you. I think it's on the agenda when somebody raises an issue as well, what you can do with that. Okay, perfect. So I presume the owner of the project needs to create some type of definition of what they want to happen with GitHub Actions. Can you take me through what that looks like?
Yeah. So inside your repo, GitHub have defined there's now a .github directory which you can create, and that's where GitHub specific files go. One example is you mentioned earlier dependabot, and you can put a YAML file in there, dependabot.yaml, and that defines what kind of dependabot interactions you want. But also within that .github directory is a workflows directory, and inside there you can create as many YAML files as you like, and each of those is a workflow definition. So within a workflow definition, there are a number of steps. There's kind of a header, which gives the workflow a name, tells it what architecture you want it to run on, and I guess we'll come back to that in more detail a bit later on. And then there's a number of jobs which define the code, and jobs can be broken down into individual steps, and each individual step is a piece of code that you want to run. So that's kind of the high level look at what a workflow definition looks like.
And before I move on to the next question, those that don't know what a dependabot is, I suppose we better define it. Do you want to have a go, Dave?
Yeah, so dependabot is a I'm not sure whether it comes from GitHub or whether they've brought it in from another company. It does a number of things. The thing when I first saw it was when I started having some GitHub pages websites within my repos that were generated using various Node applications, and Dependabot would come along every once in a while and check dependencies within my Node applications and make sure that I wasn't running versions that had known security leaks. And it wouldn't just check and give me a warning, it would actually produce a pull request which fixes the problem by bringing the dependency up to a known good version. It works in a number of different ecosystems, checking for outdated dependencies that have security issues.
Thanks. So just to summarize, GitHub has some predefined things it wants to see in its project repository, which would be on your file system, it would look like a hidden folder, but it's actually .github.
Correct.
GitHub specific things live in there, depending on what you're trying to do. But in general, there's a workflows. Is it flows?
Workflows directory, yes.
Yeah. And then inside there, anything that is does it have to be a .yml file, YAML file, or?
I think so, yeah. I've never tried putting anything else there, but.
Yeah, me either. So anything in there that it can parse and figure out, it would generally show up under the Actions tab on the GitHub project.
That's right, yes.
And just to touch on the event-driven thing, I presume you can go to the Actions tab on your project and click Go to run something.
Yeah, so I talked about there being a kind of header section in the workflow definition file. One of the options there is name, as I mentioned, but the most important one is on, just ON, and that defines how your workflow is triggered. And so it would be a list of different ways that you want it to trigger on a pull request, on a push. And one of those is a special value called workflow batch. And I can never remember whether it's an underscore or a dash. But if you've got on workflow batch in your workflow definition file, then when you go to the page for that action in your repo, there will be a button that just says run action or run workflow.
So you
just push
so
that
you could
and it runs it.
Use that to actually go to production, so it's not automated. There's someone else to push it.
Yes.
Yeah, I didn't know that. Excellent. Can the actions use Docker images, or otherwise, how do the actions get the binaries they need? As in that's your project being built into a binary or libraries it needs or something.
So the actions all run on containers, on Docker containers. GitHub supply some of their own standard containers, and there are ones for various popular operating systems. They will do some light enhancements to them. For example, they will install the GitHub command line package, so you've got access to that. So without doing anything clever, it will just run on a pretty standard operating system container. But you are perfectly able to find your own container. So if you are using one of the GitHub containers, then as you hint at, the problem is you need to install all of the software that you need in order to run your processes. So it's often a good idea to define your own container that's got the software already installed. You can store that on any of the popular container repositories. So you can put it up on the Docker Hub, for example, and then in the header of your workflow definition, you would say this runs on, and then give it the path to your Docker container. And then when the workflow is triggered, GitHub would pull that container down and start it up. So you've already got all the software installed.
Yeah, that's a good point, because I normally just run as if I'm sitting at a Debian or Ubuntu machine, all the apt-get to install the different things I need. But if I did my own container and push that to Docker Hub or some other place, I could just pull that down and really reduce some of my time it takes to run.
Yeah, this is something that I've done quite a lot of recently, because I had some actions whose job was to generate static web pages that were run in GitHub Pages, and it was using a module, a Perl module that was being installed on every run, and it was taking 5 minutes to get the container ready in order to run the software that builds the website. So I just spent a couple of hours putting together a container that had all the software installed, and now these workflows run in a minute or something rather than 6 or 7 minutes.
Yeah, I suppose it's a trade-off between you keeping your own container up to date, and
yes, now you've got one more thing to look after.
And at least, well, if there's no time constraint, I suppose. I know GitHub does bin off some long things where you can set how long it runs for.
Yes.
It does the opportunity to flex the install process and make sure it's always working, I suppose, depending on what your project is. But isn't there the concept of where did I see that lately? Yeah, for one of the deployment things that I use, and Docker in general, it's got the build image, doesn't it? Does GitHub Actions have the similar concept? So it caches the last build for you?
Yes. The honest answer is I don't know. I've never noticed it because these websites that I was talking about building, it was building everything from scratch every time. Maybe that was just because I hadn't turned the cache on.
Okay.
Perhaps. But basically, I guess I'm using the Docker Hub as a cache.
Yeah, it's a similar thing. I'll put some links in the show notes if I can find something anyway. These actions, can you reuse them? Let's just go back to the two words GitHub Actions. An action is the workflow definition, isn't it?
Well, to be honest, I think GitHub have slightly muddied the water here. GitHub Actions is what they call this entire feature. But when they are talking about setting up a workflow, they are very careful to call it a workflow definition file. So your YAML file is a workflow definition file. The meat of this definition file, as I said, is a number of jobs which are broken down into steps. And now each step is either a piece of code that you can run, so basically a piece of bash code that runs as though you were typing it on the command line on your Ubuntu container, or it's what they call an action, which is kind of an overloading of the term, because in this case, an action is a reusable piece of code that people can make available for your use in your workflows by putting it in a special format on GitHub. So actions really has two slightly different meanings in the GitHub ecosystem. But what actions really are, it's almost like a library. It's a reusable piece of code that you can slot into your steps in your workflow definition.
Yeah, it's just when I asked that question, it sort of modeled it in my head.
Yes.
So,
and that's completely understandable.
Just to summarize, GitHub Actions is like their product name.
Yes.
The workflow definition that we're in control of is what sits in our project.
Yeah.
And then if we want to shrink our workflow file or do something complicated or just, use something that's used by other people, the actual word actions is what they call the reusable blocks that you can call in your workflow file.
Exactly.
To do something that you might not be able to do, or, it saves you time because you don't have to think about it.
For example, the most commonly used action, the action that is used in pretty much every workflow file ever, is called actions/checkout. And you use that as one of the steps, one of the first steps in your workflow definition file, and that will check out the code of your repo onto the container.
And the container definition be something like Ubuntu, Windows, Mac, depending on what version you want to change on.
Correct.
And that architecture. Yeah. Okay, so I think we've defined the product GitHub Actions, the workflow, what a workflow file looks like. Those of us that have used Ansible, it's kind of similar and it kind of looks like a Docker file as well, which we've done shows on. The action's reusable because it's a separate library, as it were. Yeah. The access model, because we're using a Docker container, where's that container living? Is that a root user? What does it have access to? The thing that's running the code.
So there's a number of different levels to this. As to where the container runs, I think GitHub really want you to think about it in the same way as you would think about a serverless implementation in AWS. You don't care about where the server is running. It's just running on a container that is running on one of GitHub's pieces of hardware somewhere in the world. I haven't come across anything like areas that AWS have. You can't say you want it to run in that part of the world or anything like that. It's just a container that's running somewhere in the world. The next level is that you are running as a user on that container, and on the GitHub standard containers that they give you, you will be straight in there as root. Obviously, if you're building your own container, then that might have different setups. One confusion that I sometimes get is switching between a GitHub container and a container that I've developed myself, is that the GitHub container, like I say, puts you in as root, and then I switch to my own container and you're no longer root, so you have to sudo when you want to install. And every time I make that switch, it catches me out, and you'll see a couple of commits when I'm fixing whether I need to add a sudo or take away a sudo command. If you're not running as root, you're running as a user that has access to root through sudo, but that's common enough within a container, I guess. And then the third level is, how is that user, what permissions does that have on your GitHub repo? And the answer is, it basically runs as the person that owns the repo where it is hosted, where the workflow definition file lives. You have part of the environment that GitHub workflow sets up for you. You have an environment variable, effectively, it's not quite an environment variable, called GitHub token, which has access to the permissions that the owner of the repo has to the repo, which are by default going to be all read and write access to the repo. But you can add a permissions definition both at the job level and also at the individual step level to change the permissions that the workflow has to your repo. So you can cut back the permissions so you can't accidentally write to things that you don't want to write to, for example.
When you go to the settings of a GitHub project and you've got multiple collaborators or team members that you might have assigned different roles to or access levels, it's the GitHub repository owner that is the permission set that is used running the actions.
But then, of course, depending on what's happened, I mean, if you fork a repo, then the fork is obviously owned by a different person. So they have that. So it's the fork includes the workflow definition files, but they will only have permissions on their fork of the repo rather than your main copy of the repo.
So if you've got any secret definitions, which we'll touch on, because you're pulling some other repo or you're pushing somewhere that needs an SSH key or something like that, the fork obviously wouldn't have access
Correct.
to that environment. Yes. So some jobs may fail.
Yes, but that would be good, probably.
I've not been in this situation myself where I've had to think of that level of granularity for running bits of a workflow with different permission levels. So that's good to know. Thank you. So they state, as in the GitHub, that they offer cross-platform support.
Yes.
What does that mean?
So it means that the GitHub supplied runners, the containers that we've talked about before, they are available basically in 3 different flavors. There is a Ubuntu flavor, there is a Windows flavor, and there is a macOS flavor. And for each of those, there are some different versions available. I'm not entirely sure how far back those versions go. So when you set up a workflow definition, you say what it runs on. One of the things you can do, one of the easiest ways to get a workflow up and running is just to say that it runs on Ubuntu, and they will just pull down the latest version of their lightly modified Ubuntu container, and you can run it on there. But that also works for Windows and macOS. Of course, because you can run your own containers too, there's nothing to stop you running on a container that runs a completely different OS.
So if you're not defining Ubuntu-latest or macOS latest or whatever, would you put in that line Docker image you want to pull, or are you running your own Docker image inside the Ubuntu?
No, you run it instead. So yes, the runs on is either one of their label for their own containers or definition of your own container.
Okay, because I've seen myself mess up Docker on my workstation here, which is a Fedora one. I've then used VirtualBox to run a Debian thing and then run Docker inside that. So I thought it was something like that.
Yeah, no, I don't believe so, no.
I've personally been caught this week and last week on a couple of the projects when I use Ubuntu latest or Mac OS latest or something, and I've had to go back to a fixed version because they've changed what the latest tag is.
Yes.
And then all the libraries you depend on or different environmental variables or the bundled version of Python or Homebrew or something has changed and all your stuff breaks.
Yeah, I can understand that. What they will do is if you go to each action or each workflow, to be accurate, and each run of that workflow has a page on your repo. And so if you go to that workflow, when those changes are imminent, there will be a notice that appears quite clearly at the bottom of that page saying you are using Ubuntu latest. In 3 weeks' time, that will go from being 22.04 to 23.04 or something like that. So they do try to pass that information on. But yes, if you're...
Well, I didn't know that because I had to roll something back last week.
But obviously, if you want to be really careful about the version that you're using, then you will want to give version number rather than later.
It's a tricky one because it's flexing your software on a different version of the platform. So it's kind of good in a way, but it's noise because you haven't changed any of your code potentially.
Yes. But then presumably the people that are using your software will be updating their OS at some point. So you do want to know about those breakages.
Yeah, exactly. Similar when it's an open source project, you just don't want that red icon on your project either. Yes. So it gives you the old broken Windows philosophy. So do you have any concept of how scalable and performant GitHub Actions are in your experience?
I'm not really sure in what way it needs to be scalable. Are you picturing a repo that fires off events every few seconds that start running a workflow?
I'm thinking about maybe this is just a case of putting a link into the available images that GitHub have and how many CPUs they give to a container and how much RAM, say you've got a really RAM heavy project.
Yes.
Will that run or, will you have to pay more to get that or will it just take 30 minutes instead of...
Yeah, to be honest, I'm not sure what size the containers are that they're running.
Okay, I'll dig that out for people that want to tell you.
Performance. Well, we've already talked earlier about the speed up that I got from switching from using one of their containers to using a container that I'd built myself that had already got the software installed on it. The other thing that you can think about there is you can control what the workflow does when things fail. You might want to fail as quickly as possible. If something goes wrong, then there's no point in carrying on. So you can make things maybe not faster, but stop running sooner. So you get the results quicker by controlling the error flow.
Yeah, and that gives you a good indication if something you've done is taking too long. You can set it to bail out as well, can't you?
Yeah, and you can also, as you mentioned earlier, there's timeout. And I think the default timeout is something like 3 minutes, but you can bring that in if you want.
Perfect, thanks. I think we've mentioned it a couple of times, but if you want to store password or secrets is the general term, credentials in there because you have to go and fetch something or push something out in your continuous deployment.
Yes.
How do you go about that?
So if you go to the settings in your repo, you will find that there is a secrets item on the menu and you can go in there and you can fill in secrets. They're just key value pairs. And I'm no security expert, but GitHub tell us that information is stored in very secure manner on their servers. Obviously, it has to be a reversible encryption so that you can then get access to the values so that they can use them. But they exist at 3 different levels. You can have secrets at the organization level. So if you have secrets that are shared across repos in your organization or in your user, maybe API keys that are used by different pieces of software in your organization, or individually at the repo level. And also you can define environments against your repo, which means that you can have an environment, a staging environment, and a production environment, and you can say that this workflow is running in this environment, and then it can perhaps access a different version of secret depending on which of the environments it's working in. So you might have a different API key for development and production, for example.
That's why I love doing these shows, because I always learn something new. I didn't know that.
Good.
That's good. I've been trying to get my head around how to do something for something I'm working on at the moment.
If you go to the settings, as well as secrets and things like that, there's an environments option, and you can go in there and just set up as many different environments.
Maybe I've just fed my imposter syndrome some more thoughts there. So do we know where these actions or containers run? Is it on GitHub's infrastructure, or because it's Microsoft Azure or something like that? Do they tell us anything about that?
I don't know that it's a secret. I've never looked into it in any detail, so I don't know is the honest answer. As I mentioned earlier, I think they would like you to think about it in a serverless way. It's just a container that runs somewhere and you get some results back.
Do you know if there's an option to run the container on some of your own stuff, like a half on-prem type solution?
I was just about to mention that there is the option to run a self-hosted runner.
Do you want to just define a runner?
A runner is the container that runs your workflow.
Cool. Yeah, I'm familiar with that from GitLab type.
Yeah.
scenario.
So you can, again, it's one of these things that you can go into I think it's at your repo level, you can define self-hosted runners, and they give you a piece of software that you then need to install on wherever you're going to run stuff locally. And that then communicates with the GitHub servers and does whatever GitHub wants you to do. Yeah, you can run GitHub workflow runners on your own hardware if you want.
And that'll pull down their images and things like that.
Two most obvious reasons for doing that would be security. You have stuff that you really don't want to have running on GitHub's servers. And secondly, costs, because they don't charge you for running stuff on your own hardware.
And I suppose, that what you mentioned before, building your own image to run your own jobs on means that you know exactly what's in that image as well.
Yes.
So been doing a lot of shows on supply chain security, so that would help validate and prove for any ISO regulations or bodies that you're in to say we're in full control.
Yeah, I mean, you say that, but I've certainly never built a Docker container that hasn't been built on top of somebody else's Docker container, so that's worth thinking about.
Yeah, normally you just pull in something slim or one of these ones that have spent ages building all the different bits that Perl needs, or
exactly,
Elixir needs, or something like that. Okay, that almost finished off that section before we move on to the example project. The runner is a good example that you can just use their infrastructure but run it on your own machines.
Yeah.
So then you're in full control of all security, hardware, resources. You'll need a good internet connection to pull down the images the first time at least.
Yes.
Okay, so I'm going to move on to the last bit of our show. I think we've done a great exploration and definition of GitHub Actions, which is the product name. Then we've got the workflow that we're in control of, the file, the YAML file, and then the actual keyword term actions, which is things we can use in the GitHub Actions marketplace to run stuff for us. We then make a decision of whether we want to use stock containers or pull in our own, whether we want to run those on GitHub's infrastructure and potentially pay for that usage above and beyond what we get for free, or if we're, for example, a bank or similar, we might want to use the free runner service where we install a binary on our own operating system and that pulls down the images.
Yeah.
So let's scoop all that up and go through a project that you've worked on or you've read about that benefited from GitHub Actions.
Okay.
So have you got something in mind from that we could talk about?
There's a couple of things that maybe we can talk about, but I thought we all hopefully understand the CI/CD thing. So I think we might touch on a couple of other uses for it. Do you know the software developer Simon Willison? Have you had him on? You should get him on at some point.
I'll have a look.
He came up with a concept he calls Git scraping, which is powered by Actions. He has a piece of software called Data, which is good for looking at SQL-like databases. And Git scraping is a way of building these databases. And what he does is he uses the cron job functionality for triggering things. And he'll find a website that's got interesting data in the form of a JSON file. And he will go away and in the GitHub workflow, he will scrape that JSON file and then use Git to do a diff between that and the previous version. And then he will, obviously Git will give him a history of the changes in the data. So, I mean, he's doing things like, he's talking about websites that monitoring forest fires in California and stuff like that. And then he can, by taking the differences and putting them in his SQL-like database and using his magic dataset software, it builds websites that enable you to plot that data on a graph or build various interesting ways that the data has changed over time. So that's, I think, is quite fun and different use of GitHub Actions. I guess basically you should realize that what they're doing is GitHub are giving you free access to running cron tabs on their servers. So anything that you can think of that is a schedule, do some stuff and then store it either in GitHub or in a database is something that you can do from GitHub Actions. So the sky's the limit there, really. Another thing I've done, you mentioned right at the start that I was involved in the Perl community, and so you know about CPAN. Some of your listeners might not realize that CPAN is the repository of free Perl libraries, so add-on code for your Perl programs. And the Perl community in CPAN is very keen on, they do a lot of unit testing. So I built a site called CPAN Dashboard, which anyone who writes CPAN modules can create a pull request to my site, adding them themselves to my site. And basically all we need is their CPAN username. And then the site uses GitHub Actions to run some software which pulls information about all of their CPAN modules from CPAN. So it uses the Meta CPAN API and then produces a list of all of their modules. And they also need to tell me which CI tools they are using, whether it's GitHub Actions or Travis CI or Circles CI. And it then goes away on a schedule and interrogates all of those services and builds badges for all of those modules on all of the CI services that author uses. So it produces a rather nice visual representation of all the modules that the authors have written and how well they are doing on the various CI services. As a CPAN author myself, I use that if I've got an afternoon where I've got nothing much to do. I might go and have a look at some of the badges on that and see where my software can be improved.
Thanks, Dave. So just to summarize, because I want to go over an example project that you discuss in your book.
Okay.
So building a static website.
Yes.
Just to summarize those two examples, because I think they were great, showing the completely two different ways to do things. The first one uses the cron job function of GitHub Actions, so it goes off and pairs a website, does a diff in Git, and then does the different things that Simon wants to do. I'll put a link into the show notes for anything that you can give me about that too. And the second one is a site that you run in collaboration with CPAN and Meta CPAN, where anyone can use the pull request on action in the GitHub workflow file to run and trigger a few different things based on the fact that they forked your repository and created a pull request, and then off it all goes. So that would be a massive time saving for you in the community as well.
Yes.
Anything you can give me for the show notes for that would be great. I know it might be a simple project, an example project, but just to scoop up everything we've discussed for the sort of last 15 minutes, let's go through a static website.
Okay.
If we could highlight the manual things you'd normally do, and then what you can do with the GitHub Actions, touching on the event you're going to use, secrets you're going to have to think about, whether you're going to have to access anything else that isn't on GitHub, and how you manage that. That would be great.
So yeah, I mean, static websites are in many ways quite dull because you can actually do that without GitHub Actions at all. I've been dealing with what I call semi-static websites, which are a little bit more interesting. If you remember, it used to be quite popular in the maybe 15 years ago, the idea of a Planet website. Python had a piece of software called Planet, which basically what you do is you take RSS feeds, web feeds from various sources, and you aggregate them and you build a website that is basically a news page for a particular topic. Maybe you're interested in Doctor Who, for example, and there are various websites that publish news about Doctor Who, and different stories will appear during the day.
Yeah, I used to like those ones on Postgres or any open source ones or whatever you're looking at.
So I've got a few sites that work like this. So basically you have a simple GitHub workflow that mostly works on the cron job basis. Every 3 hours, for example, it wakes up, it pulls in the RSS feeds from the half a dozen websites that you're talking about. It then combines those RSS feeds into a new RSS feed, which it publishes, and also using probably the template toolkit, because I still use Perl for a lot of my personal stuff. It will build an index.html and publish that to a GitHub website. So it rebuilds the whole thing every few hours. But the other thing that it does is this is obviously driven from a configuration file. It could be a database, but I use a text-based configuration file, which lists all of the feeds that I'm aggregating. And obviously that might change. I might edit that, add a new feed, or a feed has gone away, so you delete it, or feeds move and stuff like that. And so the GitHub workflow definition has an on tag which looks for pushes, so a commit that has been pushed to the repo, but you can further filter the push by saying, I want you to trigger for a push, but only when the push touches this particular file. So when the push includes a change to the definition file, the config file, then it fires and rebuilds the website, pulling in the new feed or losing the old broken feed or whatever.
That's exactly what I've been looking for as well. Yesterday, I've got a project I'm working on, which is a new SaaS thing that is particular to my sector, but it's got the marketing web pages as part of the main site that has all the API backend stuff. So when I make a front end change to, say, a contact page or a pricing page, I don't really want to run the whole test suite and burn through any minutes I've got or anything like that. So that's given me the perfect idea to just say, if anything in these folders, if that's an option, get touched, then run the GitHub Action files.
So any of these triggers that fire your workflow, they all have various types of filters on them.
Yeah, I thought it was an all or nothing because it's been driving me mental.
Yeah.
Sorry, driving me, trying to think of, well, I don't want to see that fail because I'm changing this. So that's for the event workflows. So you've explained there that there's a cron job that runs every 3 hours to go off and fetch the RSS feeds. It then will commit to, I presume, another repository, which is the GitHub pages.
Well,
stuff.
actually, no, this is something that I've taught myself recently because it was causing me a problem. GitHub pages can work in several different ways. They can serve the website from a different branch, or they can serve it from a /docs directory from the main branch or from the root directory. For things like this, where I've got some processing, I take the /docs approach, where I've got all the code maybe in the root directory, and then it runs stuff and it dumps the finished website into the docs folder, and then it commits that new file from the docs folder into the repo. Now that's a bit of a problem because this is running around every 3 hours, committing a new version of the index file and the new RSS feed file. So I found it causes a couple of problems. Firstly, it means that every time that I go to my checkout of that repo on my local disk, I have to always remember to start with a git pull because there have been so many changes since the last time I worked on that file. So I need to make sure that the repo is up to date. And secondly, and this might not be seen as a problem by some people, but I was finding that a couple of my repos were the most committed GitHub repos in the UK for the whole of last year, because they were running so many automated commits. And it's kind of cheap because I'm not actually writing these. Not that the number of GitHub commits you do should be seen as a game of any kind, but it was almost like I was cheating at winning at the game. But it turns out that you don't actually need to store the website that you've built in the repo. One of the things that we haven't touched on, because there's a lot of GitHub Action stuff we haven't had time to touch on, but one of the things we haven't touched on is a thing called artifacts. So you can generate what basically ends up as a zipped up tarball. It gets stored as an artifact on GitHub servers, and you can control how long that artifact is kept for. But basically, if you go to the web page inside your repo for a GitHub workflow run and it generated an artifact, you can download that artifact to your local machine and examine it.
Is that artifact something that you've told it to generate, or is that a general term for?
There's a GitHub action called build artifact or something like that.
Would that be a binary or something to deploy? Or
no, we talked about the actions earlier, the libraries that you can use within your workflow. That's one of these. You just give it the path to the file or files that you want to go in the zip file.
Can you give me an example of what would be in that?
I use it, for example, when you're installing a CPAN module. I mean, this is probably true for other languages as well. If there are errors, it writes a log file. But because it's written that log file on your container, which has then ceased to exist when the run finishes, if a module didn't install successfully, then you don't know why it was broken. You don't know what went wrong. So if you create an artifact, you say, I talked earlier about controlling the error flow. And one of the things you can do on an error is take the log files and bundle them up into an artifact.
This would be more apparent because normally if something fails, and what I've experienced, you can go into the failed job and expand the debug logs and see it. But I presume that's only if you're spitting out the logs to standard error, or
exactly.
You're running a step-by-step to get install, but if it's on your own container or something and that's gone, the logs aren't spat out.
It gets frustrating because it says installing this module failed. For full details, see this file, and then it gives you a path to a file that no longer exists. You create an artifact, give it the path to where you know that file is going to be created, and it bundles up any files it finds, stores those on GitHub servers, and you can then have a link to download that artifact on the web page for that run. So you can download it and examine it at your leisure.
So just going back to this example project, we've got a cron job definition to run, let's say, every 3 hours.
Yeah.
You've got another event there that runs something if you do a push to a certain file, because you've done that level of granularity, not just a push to the whole project, which is how I've always done it, which I didn't even know you could do, which is amazing to learn today. Can you have more definitions, as many as you want there?
Yes.
That granularity. And you've also put the artifact job on this project as well.
Yeah, so you can have multiple keys under the on command. So in fact, if you think about it, the job that you need to run in the cron job is regenerating the website. The job that you need to run when the configuration file changes is rebuild the website in exactly the same way.
But when I tell it to, because there's an event that's triggered it, which is the push.
So the only thing that's different is the way that it's triggered. So for these semi-static Planet files, they typically all have 3 keys in the on trigger. The cron tab one, if you've changed the config file one, which might also, because the other thing that might change is I might tweak the template for the index.html file, the template that generates the web page. So obviously if I change that, I need to regenerate the file as well. But also I will put in the workflow dispatch key as well, because I just want to have that button appear that means I can manually run it whenever I want, which often helps with debugging or something like that.
That's helped me out as well, because I've been in the point where I've got a cron job that runs a static code analysis on one of my projects. So when I make a commit, I have to wait till the next day to go and see the results for some of it.
Yeah.
I didn't know about the dispatch thing because I've always only rerun them if you go into the action output and click rerun all jobs or rerun failed jobs. So that's great.
We've got 3 different triggers, but they all have the same effect, which means that I can put them all in the same workflow definition file, which is just called build.yaml or something like that. There are 3 ways to trigger that. Either there's a push on one of the important files, or it's a cron job, or I just press the button. And all 3 of those events have the same action, the same effect.
And they could have access to different secrets at different levels because you've clicked the button you might have.
They could do, yes.
Yeah.
I mean, there's all sorts of other things you can do. So you have, as well as access to secrets, you have access to things called contexts, which is information about that run. And one of the contexts is the GitHub context, like a hash or a dictionary. It's called GitHub.something, and the dot something will be the repo name or the actor, who's the name of the person who triggered the run, the actual GitHub username, the Git reference that the action is working on. Just all this pieces of information about what actually triggered the run. So you can, even though you've got the same workflow that's triggered on 3 different things, one of the things that you could look at within the GitHub context is what the event was that triggered. So you can take different actions if you wanted to.
Okay. Is there a difference of what you can do if your repository is a public one, say because it's your website or it's an open source project, versus a private one?
I haven't seen any difference. There's a difference in pricing.
Yeah, I think you have to pay for your own private stuff.
For your private stuff. All of the pricing is done on basically the number of minutes of container time that you use. And as I've got a pro account, so within my private repos, across all of my private repos, I get something like 3,000 minutes of free time every month. And anything over that, it gets billed to me and it's fractions of a penny per minute.
Thanks. So going back to your example of the 3 ways you could deploy a GitHub static site, I presume that might possibly change your development process because you've got these different things that you can only access a certain way. Is it something you need to bear in mind when you're using GitHub Actions, that things work a certain way? Or it sounds like it's extremely flexible given the...
I can't think of a counterexample. I think all of my code that I have written to run inside GitHub Actions is all completely agnostic about the fact that it's running inside a GitHub action, if that makes sense. It's code that I can run quite happily outside of GitHub Actions. It doesn't rely on anything in the environment that it gets from GitHub Actions. That stuff, all of the GitHub Actions stuff goes in the workflow definition file, not actually in the code which I'm running. So I don't think I've needed to change the way that I've written software.
Thanks. I presume this would just come down to the fact that you have to remember when you're doing your testing, you're not in production. So that's a separate thing from what you can do in GitHub Actions. You just have to do things the correct way and use your fixtures and your all sorts of different stuff.
Yes.
Okay, that finishes off the example project section nicely, which was your Planet cron job scrape RSS feeds every 3 hours, do something based on a push, and your artifacts, which I think gave us a nice overview of most of the different parts of GitHub Actions. There's one quick question that I think we've got time for before I close off. Is in your book, and earlier on in the show, you talked about what you could do, or you mentioned when somebody raises an issue, you could do something. What is that? Is a workflow where if somebody opens an issue in your project?
Yeah, so one of the triggers is, I can't remember what the name of the trigger is, but you get an issue raised, and in that instance, the GitHub context that I just mentioned would be packed full of all sorts of information about the issue, like the text of the issue and any tags that it's been given.
Oh, so just going back to the context, that's potentially a set of environment variables that you could pull on that's specific to that instance of situation. That makes more sense.
So you could add other tags to the issue. Oh, one nice thing that I've seen is things about the person that raised the issue. You can know whether it's the first time that this GitHub user has raised an issue against this project, and you can send them a nice welcoming email or add a comment to the issue saying, thank you, welcome to the project. It's always nice to have new people. There's a few things that you can do around that to just sort of automatically welcome people into the project.
Excellent, thank you. So I think we've done a great job of covering why you should use or expand your use of GitHub Actions.
Which you should do by buying my book.
Yeah, exactly. I'll make sure there's a link in the show notes for that, because I've enjoyed reading through everything and learned so much more than I thought I knew anyway. But now's your opportunity to highlight any one thing that you'd want a software engineer to remember from our show.
Can I have two things?
Yeah.
One thing that I think is worth mentioning is that I know a lot of teams already have a lot of resource invested in existing CI/CD solutions. They'll already have stuff in Circle CI or Jenkins or stuff like that. Well, GitHub have produced a thing called the GitHub Actions Importer, which allows you to easily move your workflows from a different system into GitHub Actions. So that's that's an easy way to try things out. The main thing is CI and CD are great and everyone should be using them, but GitHub Actions isn't just that. As I said earlier, GitHub Actions gives you access to containers running on GitHub hardware, and the sky really is the limit in what you can do with it. And I'd love to hear about any interesting things that people end up doing.
Yeah, there were two great examples of projects that I didn't think about with the cron things. So thank you for that. And you're my first guest that's ever had two things in the section that I say as one thing that you'd like to remember. So
I'm a rebel.
You're very
what
lucky.
can I say?
So where can people find out more? They can follow you on Twitter, which I've put in the show notes. Is that what you prefer, or is there anywhere else to get in touch?
Yeah, I'm on Twitter. I'm also on Mastodon, on fossadon.org, I think. On most social media, I use the same tag, which is Davorg, DAVORG. I'm even on that on LinkedIn. So if anybody wants to touch base with me on LinkedIn, if they want to talk about more professional things, then maybe that's the appropriate place.
Thanks, Dave. Thank you for coming on the show. It's been a real pleasure.
It's been a pleasure.
This is Gavin Henry for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.